All right, hello everybody. So today we're going to be reviewing for our Unit 6 mid-unit quiz. All the skills covered in this review have already been taught in class. This is just a way of helping you make those connections to get ready for that quiz that you'll be taking. All right, let's get started. So what you'll see here, the given question says, given the function below, as x approaches infinity, fx approaches what? So typically what will happen is you'll be given the function here on the left. Right? And what I did here is I provided a snippet of a graph of what this looks like on Desmos. And so you'll see here that as x is approaching infinity, so let's write that out as x approaches infinity, where is my f of x going? In other words, where is my y going? Typically, you're either going to go up to infinity, down, negative infinity, but if you'll see here, we have what we discussed in previous lessons, a little asymptote here. More importantly, a horizontal asymptote. We're not allowed to pass that line. Now, excuse my drawing, it's not going to be exactly there, but you guys get the idea. So that line is not going to pass that bound, and so as x is approaching infinity, so as we're going forever to the right, the lowest I can go in this case would be 0. Okay? I can't go any lower than 0 because that asymptote does not allow me to go any lower, and that's what's happening there. Okay? If I was to ask you, and this question isn't asking, but I want to see if you guys can push yourselves here. If we were to say, as x approaches negative infinity, so as I'm going to the left, as I'm going this way, where's my graph going? Well, he's going up. Well, for how much? Well, he'd be going up forever, right? So I know the question's only asking as x is approaching infinity, but I want us to push our learning a little bit there. Okay? Let's go ahead and move on. Now I'd like you to do this one. So we're being given the same situation as x is approaching infinity. F of x is approaching what? My recommendation to solve this is graph this on Desmos. Okay, graph this on Desmos, see what that graph is looking like, and then make your answer from there. Okay, so again, as x is approaching infinity, so as I'm going to the right, my f of x is doing what? Is it going up? Is it going down? Is it going to infinity? Negative infinity? Is there an asymptote? That might be a situation that's occurring here too. Graph it. Take the time. Okay, guys? All right, let's go ahead and move on to the next question set. This one is saying, identify the parent function and state the transformations for the function below. So we've done these. These are exponential functions, and we know that our parent functions, and we'll call that our PF, is going to end up being f of x equals our base value. Remember, our base value is the value that has the exponents. So we would be at 4 over 3 to the power of x. And that's it. And if you'll recall, everything else is going to be a part of a transformation. So let's go ahead and read this from left to right. As we see that negative, well, that negative is going to cause a reflection. Okay. This plus 2 that we have up here, that's going to cause us to go 2 units to the left. Remember, we go opposite directions on those. And this plus 7 is going to cause us to go 7 units up. Okay. So again, to get our parent function, you take your base value, whatever the base is, it doesn't matter what it is, it could be any type of number, and you raise it to the power of x, that's your base. Everything else that is an addition to that function is then going to be your transformations. Let's move on. So you have the same type of question here. I want you to identify the parent function. And then once you have that parent function, any additional aspect to it will be your transformations. So go ahead and give this a try for yourself. Let's move on to the next question set. So here it says identify the parent function and state the transformations for the function below. Oh, okay, cool. Well, this is exactly the same type of question. The only difference is we have that e. Now we haven't addressed what e is yet, but e is like pi, okay? It has a numerical value, so we're going to treat it as such. So if we were to identify our parent function, well, it is an exponential function, so we would say that f of x equals e to the x. And that's it. This is your parent function. And everything else is going to be a transformation. So for this, we'll have this 1/2. We know that 1/2, we're going to have a vertical compression. By 1/2. Okay. This plus 1 will go 1 unit to the left. And this -2 or -2 will cause us to go 2 units down. So the only difference of this question from the ones we just did is that e value. But like I said, I want you to treat it like pi. It holds a value. It's not a variable. A variable means that it can change. No. So pi is 3.14. E here is going to be 2.7, yada, yada, yada. And we'll discuss this later. But all you need to understand here is that e holds a value. And when we set up a parent function, it's our base. So again, e is our base. E is our base value. Okay? So now I want you guys to try this. Set it up the same way. Parent function, and then identify your transformations with e being your base value. Give it a shot. Okay, let's go ahead and move on to our next question set, and actually our last question set. So this one is saying identify the type of function and common ratio for the table of points below. So you're going to be given a table. Okay, here's our table. And they want to know, what is the common ratio? Where do we get that common ratio? Well, we're going to take our equation for a exponential function, and we've used this one in the past. So it's y1 tilde ab to the power of x to the 1. You want to put this exactly the way it is here into Desmos. And then you're going to add your table. Be very careful that when you add your table, you have your x1 and your y1. Okay? When you do that, you'll see here that we have an exponential function, right? It has that horizontal asymptote at 0, it's going, and then it starts to curve up. Now the question is asking us for a common ratio. Now your common ratio, okay, is just another way of saying your base value. And we know that in this case, our base value is equal to b. So when we look at this here, we see that our b value is roughly 4. So that means that our common ratio is equal to 4. So the skill you need to use here is taking this parent function here, putting it into Desmos as a regression, putting in the table, we've done that before, and identifying your b value. Okay? So let's go ahead and move on. Now I want you to do the same thing, okay, in Desmos. When you're doing this, you want to be sure that you set this equation up as y1 tilde of a b to the power of x to the 1. This is what you're going to put in. Make sure when you put your table, you have x1 and y1. And you're going to be looking for your b value. That is your common ratio. Okay? All right, guys, that's going to go ahead and conclude our review for your upcoming quiz. If you have any questions, please send me a message on Teams. Best of luck, and you guys got this. Bye, everybody.